Welcome back to Incremental, the continuous improvement podcast. This is our practice edition for the week. I'm Devin Bedoni.
And I'm Uriel Eisen.
And we're going to be going over some of our improvements of the last week, as well as proposed potential improvements and ideas we want to discuss, but more on the concrete nuts and bolts shop floor type of things.
Yes. Quote for the episode is, "Judge me by my best ideas, not my worst." Unknown source. I really liked it because I feel like a big part of brainstorming is dumping out all your bad ideas.
Mm-hmm.
And then in there somewhere there's a good one.
Right.
More than the other way around. And I think often, especially as you're really trying to like question everything, it's sort of hard to not delve into things that seem a little ridiculous at first glance.
Yeah.
Like, what if we turned our mill on its head? What would that do for us? And it's like, if you're not willing to entertain it, you're probably going to miss a lot of.
Yeah. I sometimes have frustration in my home life discussing like new ways we could try a thing, and certain individuals just like before I even said anything, there's just like a no, can like see it, and I'm like, I'm not saying this is how it has to be, but let's talk about it. Like,
yeah,
I know it's a bad idea, but there might be a good idea in there somewhere.
Yeah. And
I think that's very much how I work, is like, well, what if we just threw it all away and then see what happens? And not everybody likes to do that.
No.
Yeah, I think that's good. I think as long as there's, I think, I guess it's ideas, not actions.
Judge me by Yeah, that's probably a useful distinction.
For a second, I was like, oh.
Yeah.
But yeah, I like it.
Well, in prototyping, there is something to it because prototyping is about learning more than it is about execution.
Mm-hmm.
And I mean, you're executing to learn rather than executing to like.
Sure.
And I feel like building crappy, like prototypes that don't seem like they should work, there is value in that. Like everyone writes off an idea as a bad idea.
Right.
Actually building it sometimes is useful.
Confirm how it does and does not work.
Yeah, sometimes it's like
matches.
Well, it actually does work, or yeah.
Oddly.
I was doing a project in water filtration years ago, and we were doing a lot of stuff with like welded films. And my brother Alicia came to visit, and we spent like a day prototyping different ways of making tubes from welded film is tough because the capillary action seals the two sides of the tube together if it's patterned flat, so everything lays flat. And so to get water to flow freely through it is really tough. And so we ended up just like prototyping all sorts of weird ideas with like extra bits inside to try to keep the film apart so it didn't sort of stick together.
Yeah.
And we did prototype a lot of ideas that were just like, that probably won't work, but like, let's try it.
Yeah.
And that was a combination of like, it was cheap to try.
Right.
But yeah. And
it can be challenging when it's not cheap to try and there's like significant like construction hurdles involved.
Totally.
That definitely mucks up the works.
Yes.
But if you could build everything out of silly putty and test everything out of silly putty, that would be pretty cool.
Yeah. I was just talking to someone who's designing an overlanding like pod that goes in the back of their truck. And he's spent like 2 years in CAD.
Oh, wow.
And I was like, have you tried building it in cardboard? And he was like, yes, I recently did it in cardboard. And it was really useful.
Yeah.
So like that's a cheap version of an expensive thing.
Yeah, you just need a knife and some duct tape.
Yeah, exactly. Yeah.
Yeah.
And just order enough Amazon Prime and well on your way. Why did you buy another refrigerator? I needed a big box. All right. So some improvements.
Yeah. I'll jump off. We started color coding our new job work. I'm calling them a work order slip. I don't know what to call these things that I'm using on this job board to organize Sometimes we call them a traveler. Sometimes we call them a work order slip. Sometimes they're just a job. I don't know.
Okay.
Anyway, but you know what I'm talking about. These things. So we added color coding for due date, which was helpful.
And a brief update. This is a piece of paper stuck to a whiteboard.
Yes.
And the whiteboard has divisions on it that represent the stages in your
process
shop that it needs to sort of go through.
Mm-hmm.
Cool. So you added colors to the paper to indicate due date?
Not to the paper. We got colored magnetic clips.
Oh, nice.
That hold the paper.
Smart.
And so right now we're dividing it into 4 weeks, basically.
Oh, cool.
And we have a color for each week. And so basically if a due date falls within that week, it gets that color. Or if we think we have room early, I don't anticipate that happening much for a while.
Yeah.
And then there's a corresponding magnetic, just like a colored magnetic tag that's a dry erase tag. And so we'll just dry erase the date for that color on it. And it's just,
nice.
They'll kind of like travel along. And then you kind of like, the idea is when you get to basically complete in the process, there's going to be a colored tag with that due date week at the top of the board.
Mm-hmm.
And pretty much everything in that column should be that color. And if you see stuff that's of the next color, of that color or the prior,
right,
that's behind schedule.
Interesting. Has it been useful?
It was useful, yeah, because it was kind of like a running start. I gave us, and a lot of stuff was sort of in process. I kind of like started it 2 weeks delayed because I
understand what you mean.
There was a bunch of things that were like about to ship and about to be done that I didn't bother putting into that color coding system. But so we're not seeing it like highlight delays yet, and we'll see how functional that aspect is.
What was the need you saw that made you want something like this, or what was the
having better visibility into just how long things have been in the shop, basically. And so like if it's obvious that something, sometimes it's hard to tell, like weeks just seem to blow by these days. And
I know what you mean.
Yeah, we got an order, it seems like it wasn't that long, and then you go back and look at the order date and you're like, oh my god, we've had this here for a while, like I'm sure they need these. So that's part of it, is wanting to satisfy customers, and then also just trying to internally get a sense of what our load actually looks like on the different work centers.
Load, so there's a question about what order things should go on, and so by seeing the due dates, that lets you make decisions without like going back and checking emails or something like that.
Yeah, and also just in terms of quoting new work, it's pretty easy. So like I haven't done like a discrete. I'm kind of trying to take this in stages right now. I'm not saying like, okay, I have this much work like scheduled for that work center, that's a week's worth of work, I can't put anything else on that color. I'm not doing that yet. But in theory, we should be able to start to do that and say, oh, we're booked out 4 weeks, or we're booked out 3 weeks on these work centers. This one, we're only booked out 2, kind of a thing. That's down the road and not something I'm trying to tackle yet. But right now, it's also what the most useful thing so far has been seeing sort of all the work centers next to each other, and then being like, oh, in my head, I kind of put these all on this one work center for one reason or another. This other one is empty. I'm going to reshuffle and figure out how to move things around based on due date. And so I think we'll be able to start like balancing the load across the work centers much more effectively to be able to hopefully have a more consistent flow through everything in the shop.
Interesting. Yeah. So, I mean, this is like big time visual management, right? Which is like a huge emphasis in Toyota production system, where the state of things should be visible at a glance. I feel like every time I've taken a step in that direction in our shop, it's been like, wow, look at that. Like, that's so easy. And I feel like you forget about all the time spent digging back through. Like, I just did this where we had a big order. We're changing our sort of SOP for like how we handle big orders, mostly just in terms of the date.
Yeah.
Which is like, write the date they're due.
Yeah.
When you put them on the shelf.
Yep.
Because then it's like, Sam will be like, oh, like, how many should we do this week? And I'm like, let me check. Like, let me check when they want them. And
yeah,
it's like all wasted time.
Yeah.
And yeah, so.
Yeah, no, that's super critical. So the other update we made to that was we reformatted the actual printout.
Okay.
So now we have check boxes for basically all of the processes that we do in the shop.
Okay.
Kind of like we talked about last week with being able to, fill out if there's redundancy because if something is a repeat job or things happen out of sequence, we can notate that. We also separated out mill and lathe runtime boxes so that if it runs on one or the other or both, it's easy to distinguish.
Gotcha.
And I don't remember if I mentioned this. There was this funny thing where I was imagining half days as a unit of like time.
Yeah.
Because I was like, there's a lot of jobs that don't run a full day. So half days are the unit. So I put on the first slip that I made, I put like machine runtime in half days. And so I would like write out a whole number in half days. And then and then at the top of the board, like each category was like, we want to have this many days in it. And so you're having to do this like funny half day, full day.
That's funny.
And Coram was like, why can't we just use days? And I was like, no, it's because the unit's a half day. And he's like, well, why don't you just write 0.5? And I was like, I'm such an idiot.
That's very funny.
So I converted it back to full days.
Okay.
Or at least language of days.
Right.
Not half days. And
it's
going to be helpful.
Yeah. That's very funny.
It was remarkably confusing.
I could see doing that also.
Yeah.
Being like, well, we're doing half days. It's 2 half days. That's very funny.
Yeah. So that was good.
Nice.
And I think can be helpful. Yeah. Having the due date color coded so you can make sure things are flowing in sequence according to their due date is helpful. There's some questions like things that need to be anodized. We kind of have to move through quicker because their due date has to account for that extra time.
Okay.
Of being out of the shop after they're done.
I see.
You can't be like, oh, it's running. It's going to be delivered this week, and then be like, crap, we have an extra week to add on here.
Right.
Got to do a little thinking there, but
could you eliminate that by writing a due date for like machining and then a due date for shipping that's separate? Because you're only trying to sort of optimize this stuff through your machining centers.
Yeah, that's a good call. I like that.
And then convert back to half days. No.
Half weeks.
So what waste would that be, the half day to full day conversion? Is that just wasted human potential? It's also probably, is it over processing?
Sort of over processing your information.
Yeah.
Yeah. It's definitely waste of human potential.
Definitely, yeah.
Waiting probably as well. It's like there's
waiting for your brain, or what are you?
Yeah.
That's funny. On the topic of waiting,
yeah,
I've been messing with I don't have this written here, but I've been messing with our sewing machine because we have a job for a company in Europe that wants a bit of different sewing with more elements, which they're hard to hold all in place while positioning it in the sewing machine. So you can there are companies where you send them a sample of what you're trying to make, you send them all the bits, and then they come up with fixturing and send it back
for sewing specifically.
And it's typically thousands of dollars. And then the sewing machines themselves are designed, Shigeo would not approve. They're designed to basically like an industrial sewing machine does one thing, and it's set up to do one thing.
Yeah.
And all the tooling on it is set up assuming that you're going to be doing that one thing for weeks at a time. And so it's all like a bunch of screws, and it's very annoying to switch jobs.
Yeah.
Because like the incentives for the people designing it is basically like make the cheapest thing, and then it's going to sit on the floor doing one thing.
Yeah. Right.
And so for a lot of small shops, that's not really the reality of owning an industrial machine. You're switching jobs because they're thousands of dollars, right? Mm-hmm. The other thing that's a big advertised feature of these machines is the sewing speed, number of stitches per minute. And I was thinking about it. The only reason that is an advertised piece is because all setup is internal setup time. So SMED divides things into internal setup time and external setup time. Mm-hmm. The second you have two fixtures that flip-flop in and out of the machine, just like your R450, mm-hmm. the sewing speed is like, it doesn't matter basically, because the loading time is longer almost always than the sewing time. Right. And so if you're just sitting there loading fixture while it runs, you can slow it way down. Because I was having an issue. I wasn't having the issue. I was anticipating.
I get what you're saying. Like a full pallet changer, not just quick, not single minute exchange of fixtures. But
no, literally just I set one up while one is running. Suddenly it's like I can slow the machine way down. And the advantage to slowing down the machine is it sews better. It wears out slower. And so I was anticipating having a problem of having too much inertia on the table.
So wait, are you actually doing this? You're making a pallet changing sewing?
Not. If you saw it, you'd be like, oh. Yes,
you are
essentially.
making pallets that you can swap
and they just locate on a feature that's glued to the table of the sewing machine.
Oh, that is very cool.
It's very simple, but effective. So I guess.
Yeah.
Anyway, the inertia of the clamping, I was anticipating potentially being an issue. And then I was like, wait a second, if I just make two of them, suddenly we can just slow the machine way down.
The inertia? Sorry, I'm not.
As the sewing machine moves this fixture around, the sewing machine doesn't move. It jerks around the fixture to get to its different stitch points.
Sure.
And so I was like, anyway, so just like, and then I was kind of looking at it, and it's like in all these sewing factories, there's a lot of waiting happening where they're waiting for a sewing machine, like a programmable tacker, to finish. Because the programmable tacker is expensive. And so people don't buy multiple and then have one operator working two machines or something like that typically. And the cycle time is normally like 7 seconds. Right? Not like 10 minutes. So... But there's an alternative, which is changing out the clamping on it and coming up with a quick way to do that.
Yeah.
So right now our system is not very quick, but there's a bunch of ideas of how to make it quick.
Do you have a sense of why this hasn't been tackled in industry? Is it just because it's probably not a bottleneck for those companies?
I think it's a few things. I think it's 7 seconds, so it's very short. And they look very fast. And historically, they are very fast. Like switching to these programmable tackers from like...
Yeah.
Inherently for sewing to be... Like right now, it's very hard to sew anywhere that doesn't have very cheap labor.
Yeah.
Hard to get people to pay enough.
Sure.
And then...
Because you're paying someone to stand there most of the time.
At the end of the day. I think partly. I think the other piece is this would add a good amount of expense. And I've had this experience where like the upfront cost of these machines is substantial. Like this one was $7,000. The one I would have liked to get was $15,000. And it just felt like I'm not going to spend $15,000 on a sewing machine right now.
Also a sewing machine that does one thing.
Yeah, that one. Right. And like, I don't know. It has more features, but we don't need them immediately. So I would imagine if someone came out with a sewing machine that has like a quick change table, most production lines right now, basically someone just sets up a whole bunch of machines. Like we need a machine for each operation. They set them all up. They put people on them, and then they pass garments one to the next, or bags, or whatever it is. And so the whole method of production in sewing is done in a way that doesn't, I don't know. like instead of having one machine that sews two different things and has a quick change between them, and I think it's just not done. Automation in sewing is a huge nut to crack,
right?
And a lot of people are working on it, and it's very difficult because
fabric is
moves.
Floppy.
Yeah. So there's a lot of interesting work. I think for all those reasons, it's just like hasn't been done. And then the last piece, which we've experienced with our milling machines, they were built for one thing, and we are using them for something else, right? Like they were built. Like our machines were built for like automotive or like a specific task.
Yeah.
And then the second you're outside of that, you start bumping into the ways that they optimized for the other thing and not for what you're doing, I think, essentially. So
interesting. Do you think, we're getting a little off topic, but do you think if/when the sewing industry starts to bump up against labor costs to a higher degree, these types of advancements will happen?
Probably not the one I'm talking about necessarily. There are some sewing machines that are more like 50,000 or like more than that, and those do have interchangeable tables and stuff like that.
Oh, okay. So this has been done, just not with your machine, basically.
Yeah. And so I think it's sort of like a cost of the machine versus like the cost of coming up with this fixturing. Most fixturing is thousands of dollars. I was just like, what if I just 3D printed it? So I just did, and it worked. So, so I'll be 3D printing it. I think that the bigger advancements in sewing, like there's a lot, possibly on this stuff, but really what needs to be solved is much bigger.
Yeah.
My personal feeling, and this is really an off topic here, but is just that like it seems like there needs to be more collaboration between the pattern makers and the robotic sewing people, because there's a lot of like bag designs and stuff like that could be automated. If you designed a bag specifically for automated sewing, you could do that.
Like adding holding features and all that kind of stuff.
And like the way you get a 3-dimensional sewn object from 2-dimensional fabric can either be like two curves that come together, or it can be a series of straight lines. Like there's just stuff that's going to make it easier or harder, and I haven't seen that collaboration happen where like there's a vertically integrated. It's not true. You know those Klein bags, there's like a zippered pouch for an electronic shop, like electrical shops. Zipper canvas says Klein on it.
I know the company Klein. I don't know if I know the bag off the top of
my head. Those bags, I talked to the guy who made the product line that makes those bags, and it makes them in like I forget how many seconds. And it's all like no one touches it, right? You load the fabric in, you load the zippers in, and it makes bags.
Wow. You're talking about the little teeny zippered ones that are like a little tiny tote for like your screwdrivers and stuff?
Yeah, exactly. Yes.
Interesting.
So you can see how that would be a lot easier to fixture because it's not actually 3-dimensional. Until you stick screwdrivers in it.
Very curious.
Anyway.
Yeah, that's a whole world I mean, I've sewn some stuff in my day, but not thought about it in terms of a production process, and it's very intriguing. And it's crazy how much, like, I think just probably because it's in other countries, much more so than like, but there's no real sewing here
except DOD,
right? Yeah, I think we just like, but there's sewn stuff everywhere, and we engage with it every day,
right?
Totally take for granted that the stuff's just made somehow, somewhere.
Yeah, and there's been advancements in pouching, which is similar. Like you'll see, like I just bought sour cream in a pouch instead of a and like those, if you look at how those pouches are constructed, that is all highly automated, where you load film in one end. And there's been advancements in like it's called web processing product lines, and the cool innovation there, and then we should probably get back, but the cool innovation, and this was sort of that out of the box thinking kind of, was basically looking at the web as, so if you think about feeding a piece of paper through a printer, which is a web feeding through a machine.
a web being like a two-dimensional, like
a two-dimensional piece that only likes to bend in one direction at once.
Oh, okay.
Sheet metal, non-stretch textiles, plastic film, paper. So like when they print the New York Times and it's going at like 50 miles an hour through the printing press.
Yeah.
You can imagine how easy it would be to get a wrinkle and then just a huge jam. Right. And so the cool innovation was they thought about that as a mechanical piece of the structure and then designed out over constraining that web. And so like
they purposely over constrained the web?
They purposely eliminated over constraint of the web.
Gotcha.
But that was like, before that, it was like these artisans would build these presses and they had to be so precise to not wrinkle paper as it fed through. But someone was like, that is a mechanical object.
Right.
Like if you pretend it's not moving for a second,
right,
you can just go like, oh, it can't be over constrained. And
interesting. It's like a stressed member almost.
Yeah. Hopefully not too stressed.
Yeah.
Yeah. Only in tensile.
Yeah. Wild. That's cool. Things you learn every day.
The more you know, the less you know.
That's how I feel building my house.
Yeah. We've talked about the 4 stages of knowing or something.
What are they again?
Unconsciously incompetent, to consciously incompetent, to unconsciously competent, to consciously competent.
Yeah.
That first transition is always painful.
It's
You're just
rough.
like, oh my God, there's so much to know. I had no idea. Yeah, a few improvements in our shop. I added a fume hood to our gasout oven. So we take parts and throw them in an oven at 300 degrees for an hour before coating. And that's to make anything that may be tempted to become a vapor, become a vapor before you put paint. Otherwise, you end up with bubbles under your paint, basically.
Here's your chance, kids. Knock yourself out.
Exactly. And the cure temp of the paint is 250. And so you go a little bit beyond that and then you're safe.
Does it have to go for a full hour?
I don't know. This feels like adverse incentives where the incentive of the paint manufacturer is to give you a recipe that
reliable.
Exactly. And it's like, are you guys doubling this? Are you 1.5ing it?
Yeah.
Could I go to 350 for 10 minutes? Right? Like,
I mean, it really, I'm no expert.
Same.
But it really seems like volatile compounds.
Yeah.
Like they have the word volatile in them. That means they tend to do it quickly. And if you're not actually trying to burn the stuff and react it,
right,
it would sort of seem like it would happen very quickly unless there's a lot of it.
So back to the definitions from last episode. Yeah. What are the compounds that we're trying to get off, which might be part of their, like, we need to give an hour for anything conceivable,
right? Like if there's motor oil,
that's very different than like coolant,
or I don't know what finger oils are like in terms of their volatility. It just seems like maybe it's probably not a constraint in your but painting seems to be a constraint in your process.
It's all time that stacks up end to end. So
it seems like if you could do some small batch testing and cut that down to a reliable 10 minutes or even 5 minutes, that could be a huge win.
So that's a possible improvement there. Dig into that.
Or I don't know, maybe increase the heat and
right. I wonder if like
time.
Steam cleaning would be quicker.
And
then it would flash dry because it would be hot.
Steam cleaning is very cool.
I've
used some of that working in a winery. It's like very effective, obviously very clean, no harsh chemicals,
right?
All that stuff. And also in jewelry sometimes we would use ultrasonic cleaners to clean off the rouge, and sometimes in like very tight corners it wouldn't come out, and so we would use steam to clean that, and it was pretty effective.
Very cool.
It just melts the stuff away.
So I added a fume hood over that oven because I was just smelling it sometimes and I was like, I don't want to breathe that. So that was very nice. It always feels good I feel like as a small shop owner, it's easy to sacrifice your health. And it always feels good to
the
be
business
like, no,
is built on sacrificing your health, probably.
So we did. So that was great. got this one's funny. So we have this spring inserter mechanism. It's 3D printed and then has a whole bunch of springs that are lined up in this sort of rack, like a magazine.
Yeah.
And I had prototyped it, not sure if it would work, so I just threw something together and it worked, and that's what we've been using for the past year and a half. And Sam the other day was like, could we like design a longer magazine so we could just have more springs in there so I didn't have to keep stopping to refill it, which is batch work, and it is it is bad, but it's also a good next step. Like overall,
is batching bad if you're just like feeding? This is a question. Your fundamental process is still single piece flow. Always yes. Like your assembly process is still single piece flow.
Yeah.
So what is the theoretical disadvantage of batching the magazine aside from potential inventory? But you already hold the inventory, so you're just talking about having a person go get it less often. If there was defects, I guess, but you've already paid for the stuff. So what's the disadvantage there?
So the way I look at it is, if you push it to, it's always interesting to see how systems act at their limits.
Yeah.
And so if I said, okay, I'm going to make a magazine that holds 10 million springs.
Sure.
Okay, let's not blow it all the way out of the water.
Whatever.
I order 3,000 to 5,000 at a time.
Yeah.
Let's say it holds 3,000 springs.
Yeah.
That would take quite a few hours to load, and we wouldn't get to we wouldn't essentially capitalize on that invested labor for potentially a couple months. And so if you like looking at it that way, it makes no sense to invest the labor ahead of when that labor turns into shipped product. So I think that is the waste. And so the second you're moving to a bigger batch, you are essentially admitting defeat on eliminating the waste of orienting the springs, and like it is annoying to do. And so instead of solving that problem of they're annoying to orient, you're instead sort of just hiding it and sweeping it under the rug and making it hard to observe. Like we've talked about this, part of the point of single piece flow is to make the inefficiencies more apparent, which is why everyone says, surely that's not more efficient, is because if you tried to do it, it is way less efficient, right? Because you are suddenly doing every activity one time per piece instead of one time per 100 piece or one time per 10 piece. And so like I've even had the thought of like, what if just for the sake of it, you did an activity where every movement instead of doing it once per part, you did it 5 times per part. Like, I feel like it would suddenly elevate the annoying, pointless parts, like picking up pliers, right? You're like, oh my God, and reach for it again, and again, and again, and again. And now I get to do the thing. It's like, let's hang these from a string right above where they're needed.
Yeah.
Right. Like all these things, it's sort of to highlight the inefficiency, to make it more apparent, because what everyone has historically done up to the point of, well, I'm sure there's exceptions, but like Toyota made this realization that people are basically amortizing their waste instead of solving their waste. And that's the reason everyone was moving toward bigger batches was to amortize it over more pieces. And instead they said, well, let's just eliminate it.
So interesting. I didn't realize there was like an annoying aspect of loading it. So that makes a lot of sense. I guess there's the potential to find defects, although who knows?
We found defects. Yeah, and actually this is an interesting example of pokeyoke. Unintentionally, I made the opening of this spring magazine kind of constricting. It turns out that it catches defects, so you can't load them, which is
that's cool.
Nice, and now something I think about.
Interesting. And one other thing, I guess this would be another place you could like look at applying the synchronization of production. Like if you do it in a batch size that matches your daily production, then it's like you are guaranteeing that the labor put in that day ships that day, right? Versus, it does seem like there is kind of a happy medium in there somewhere where it's like, if you're doing this, if you're reloading it 6 times a day, for something like this, like if you're going to actually solve the problems inherent, then maybe leave it. But if it's like those problems are not something we're going to solve right now, then maybe, you do extend it and match it to your production for the day. So you do it once.
That's basically what we did. Yeah. It's like, we will solve them. It's not going to be now.
Mm-hmm.
Let's put a Band-Aid on this where it's just less annoying until we move toward that. Yeah. So the next, I spent a bunch of time on Friday designing a new assembly fixture. And the change was keeping the spring feeding mechanism static. In the current version, it moves. And instead, another part of the assembly fixture moves. And that allows us to feed it with a vibratory bowl, because the vibratory bowl can be static.
Oh, right. That's the impending solution.
Yes.
Is the vibratory
so again,
bowl.
Not going to be anytime soon, because it's such a small... We barely spend time orienting and loading springs.
Yeah.
But it is a thing we spend time on. And really, the question is, if someone placed an order for whatever... 1,000 buckles a month of all the same color, what would that look like?
Yeah.
And suddenly loading 10,000 springs into, would be pretty annoying and time consuming. So
this kind of like points to, which we didn't really discuss last episode, but kind of like the distinction between theory of constraints and lean or TPS. And you and I discussed this briefly during the week.
Yeah.
Kind of like, what is the difference between these two things? And this sort of points to maybe what theory of constraints is trying to solve that TPS doesn't. And that is highlighting where you need to focus your improvements. And
totally,
this might be one of those things where, like, yes, by strict theory, you should maintain single piece flow and solve every problem inherent in your spring loading process.
Right.
But looking at the business as a whole with a throughput goal, like, this might not actually become a constraint until a size at which you may never achieve.
Yeah.
So it's probably not worth spending time on potentially.
Yeah, I think part of the idea of prototyping toward learning rather than prototyping as like a rev system or something like that. One question that's been on my mind lately is, what is the floor for the cost of our production of these parts? How low can we go?
On your side, on our internal cost side.
Internal cost side, yeah. And there's a few question marks to me. There's ones I know, right? I can get a quote for, instead of ordering 500 pounds of aluminum at a time, I can get a quote for ordering 10,000 pounds or whatever, right? Like, there's the stuff that's easy to figure out, and then there's stuff that sort of there's a few cruxes that I see. And so it's not necessarily the bottleneck, but I would hate to send someone a quote for a very, very low price if they promised to buy 100,000 pieces that then I couldn't achieve.
Yeah.
Conversely, I would hate to send them a quote that they hated when I could have gone lower but didn't realize it. So there's sort of some learning that I want to do now, even though it's not a true bottleneck. Similarly, the sewing fixturing is for this one job. They didn't order that many pieces. It did not justify me spending, 6 hours in CAD. But one of the reasons we decided to do it is internally, sewing is a constraint on scaling because it's a really skill heavy process. And so someone needs to practice for many hours to get to a level that we are okay shipping. If we had fixtures that were extremely low skill to load, that would suddenly alleviate that constraint.
Yeah.
Where I know now I can just 3D print extras. I can hire a bunch of flex workers or whatever, and they're going to successfully load these.
Yeah.
So.
Interesting.
Yeah.
I have another tangent.
Hit me.
In that Gold Rat presentation, whatever you want to call it.
Beyond the Goal.
There was the discussion of engineering a sale. And part of that was not lowering prices. And not using that as a lever.
Yeah.
And I'm it would seem like maybe I just didn't hear all of it yet, but I'm interested to explore this idea more, because I think it comes back to the kind of what we were talking about earlier, and not letting cost be your driving factor all the time. And that how maybe driving down costs as the primary goal doesn't actually develop good business relationships.
Yeah.
And clearly, like, lowering costs is important, but also what am I trying to say here? How do we kind of bring the other levers into the picture in a way that cost can be less of a lever, except as something that benefits everyone, maybe in the supply chain, and everyone in the whole system through to the consumer?
Yeah.
But stop focusing on it as like our primary lever to pull with sales, or a significant lever to pull with sales. This is a question, a tangent, an exploration that I don't have an answer for, but
totally
his insistence on that in that speech was very interesting to me.
Totally.
That, like, well, as he said it, you never lower your costs, because then you're just asking for a price war, because somebody else can also lower their costs if they do the same things that you're doing.
Right.
So what is it that you're bringing to this interaction that is unique? What else are you providing to your customer that is unique aside from low cost? And I don't know. It's interesting as we look at these things and focus on lowering cost, how do we not shoot ourselves in the foot, essentially?
Yeah. So I think, a few comments. One, if you look at Prusa right now, they, I don't know what the future holds, but like Bamboo came out, 3D printer. They're both 3D printers. Bamboo came out at the same price point, offering a lot more.
Isn't it even lower?
Whatever.
Like one of them
it's
is
very comparable. One's like, they're right around $1,000, a little over, right?
Yeah, in the range.
Yeah. And so I think that is true, but I think it's worth recognizing. And you saw the same thing with like US automakers, right?
Yeah.
They made cars. They're like, this is what a car costs. And then someone else spent a bunch of time, 2 years actually, more than 2 years, figuring out how to make it much cheaper and much better. And then they came out and kind of...
You're referring to Japanese automakers?
Yeah. And then same with like Kia, right? Kia was not great. And then they figured out to make a very cheap car and brought their quality up. And so I think it is true, but I think there is an abdication of responsibility sometimes with manufacturers that start priding themselves on a different aspect. So I think there's both. I think it is really
both and.
Yeah, it's like it is really important that your value add is not just like we offer the lowest price, unless that is your value add, right?
Sure.
I think it's really important. Like for me, one thing we were just talking about the other day is like we make really fancy buckles. They are expensive. The only complaint we're going to hear in every single deal we try to make is their cost, right? The quality's great. The aesthetics are good. Like it's all great.
Sure.
Except the cost. And so we should not respond to that by saying, okay, we'll drop the cost. That is not the response. The response is, okay, well, it's not a good fit for you. Like there's plenty of cheaper options. You know that. Go buy them. Right? And the reason to not drop our cost is because we need to find people where the value add of nicer hardware is a real value add to the end consumer. And if we don't put ourselves in a position to learn that lesson, we're going to chase the bottom and then not have money.
Yeah.
And so, so I think it's a both situation. It's like, there's people that come to us and they're like, we love your product. You know, what do you think? And I'm like, just thinking about it. The things we offer are not things you need. So like, just go buy the other stuff. But then there's people who like, I made this out of frustration from personal use that no one else was solving.
Right.
And so like, we need to find more people who are in that scenario.
Yeah.
So yeah, I think it's both. I think it's really important to not, cause look, I'm also going to get knocked off, right? Yeah. At some point, someone's going to knock this off. If they can't do it cheaper than I can do it, they're going to have trouble knocking me off.
Right.
And I don't think that's unrealistic for me to do it as cheap as anyone.
Yeah. Yeah,
both
totally.
If I chase efficiency and if I know that the equipment I'm using is the best equipment out there from a value perspective.
Yeah.
So I don't know. Yeah. I think both. But yeah, I think it's a very good point, which is, yeah.
Was there a point? I'm just teasing this.
Yeah. Spend time thinking about what is the value you can bring to the table that is not just, we'll do it cheaper.
Mm-hmm.
I don't know.
Interesting.
Other little improvements. We added a part counter at the sewing machine.
Yeah, just like a click.
Yeah. I took some e-tape and taped it to a block of aluminum so the orientation stays convenient. And it has really helped us level production in a numerical way.
Yeah. And so when you sew one and hit the button, basically?
Yep. And yes, we could tie it to the sewing machine, and yes, there's a bunch of stuff, but already it's just like really informative and nice to have a real number that we can look at throughout the day.
It's one of those things I keep coming across this too, where it's like something is infinitely more than nothing.
Yeah.
Even if if it's not, even if it's so minimal, like I keep experiencing this where it's like, okay, I have this idea. I'm literally just going to start the placeholder, which seems like nothing, but it is infinitely more than nothing.
Right.
And it opens the door for everything else to come after.
Yeah.
And I have been so guilty in the past and still of not doing it because it's not even in my head. It's not even close to where it needs to be. Right. Just keep coming back to that.
So
something is infinitely more than nothing.
Totally.
So just do the something. You'll figure out how it needs to be better as you go.
I feel like I sort of made a career out of that in a way that I felt bad about for years because I would just like try stuff. I remember like growing up, I would just like try really simple versions and like build stuff out of cardboard, build stuff like string and whatever. Just like, does this work?
Yeah.
And I was always sort of like, man, I wish my stuff like looked nicer.
Right.
And I wish it was like more polished. And then I'd see these photos of stuff people built and it's like, man, like that's so cool. Amazing. And mine kind of sucks. Yeah. And then I went to college and I figured when I went to college that everyone would be building stuff at such a high level that I would like, thrown in the deep end basically. And I ended up doing a bunch of work in the Robotics Institute with Red Whitaker, who's like a big name roboticist.
Okay.
And he just loved me because he had all these classes where they'd spend a semester and he'd be like, this is what we need, the problem we need to solve. And people would plan and plan and plan and plan and plan and then start building this final thing. And then it would have all these problems that you couldn't foresee. Yeah. But you could have tested early with really simple prototypes and then been like, had a really much better solution and it's like, it's that hesitance to like make something crappy. And like one of my, this week, one of the things I'm going to give Sam is to make us some headphone holders out of cardboard and hot glue. Because, right now they just rest on a shelf and it's annoying. And
you're talking about ear protection?
Yeah. Just like little cubbies, and it's like, oh, they should be plywood, and we could like round the corners, and we could build a nice little cabinet or what, right? Like you can so quickly like scope creep that project. Yeah. And to your point, like something is so much better, like it's infinitely better than nothing, and then you'll start to be like, oh, this angle's wrong. Oh, this could be smaller. Oh, what if we did it this way? I don't know.
Yeah, I've really enjoyed having the 3D printer for that. I also do think I need to like get some of these other like basic supplies like a hot glue gun, which I don't have. Yeah. Or even just like a bunch of coat hangers or something. Totally. That we can just like have to bend and like make stuff. Like I always used to also feel bad because like I just put screws everywhere to hang stuff on. Same. Right. It's just like, it's ugly. Like, right. I should get, I'm just like, walls are peppered with screws, but it's like it takes 2 seconds and now you have a place to hang your stuff. Yeah. And then you unscrew it and screw it in somewhere else when you realize it should be moved. And then maybe 5 years later when things are really like in a good system, you buy an actual hanger or a hook and put it up, or maybe not. I don't know. But
yeah, and I think like, I don't know, like you look at lean tours, like shops of like tours of really, really clean shops, and I think I've talked about this with a few folks. Like Kaizen foam is this foam that you cut out a profile so a tool drops right into it. And I think the challenge to me with Kaizen foam is that it makes it really hard to reorganize. It makes it like very binary. You're either cutting a new piece of foam or you're leaving it exactly how it is now. Like we start anyway. So like, unless you treat it as like, okay, we'll make a new one next week if we have to.
Yeah.
I think like this idea of like prototyping and like PDCA, I think it's important to take steps toward things. Like even with Kaizen foam, it's like maybe spend a week, maybe organize your drawer how you think it should be laid out in Kaizen foam. Trace it on a piece of paper, cut it out of cardboard,
try it,
cut it out of foam and commit to redoing it. I don't know, right? Like, yeah. Put a screw in the wall, hang the thing, realize it should be hung somewhere else in the shop.
Yeah.
Move it over there, then build it at home, or I don't know.
Yeah. Yeah, totally. Interesting.
Incremental.
So sort of a tangent, but something I want to talk about with you. We bought the R450 pallet changing mill with the express purpose of automating it.
Right.
And we have not yet, because we ended up with a bunch of work that would run on it very well manually. Automating it's been a little bit of a lift just to get all the fixturing built and whatnot. However, in the last 4 months since we bought it, and all the other realizations about our other machines and kind of where our efficiency might be at, kind of the hurdles we're facing that have come to the surface since then. It does such a good job at manually loading work that I'm wondering if that is sort of a fool's errand to automate, to focus on automating that while not automating our other machines. And that if we could automate our other machines, that would be a much bigger addition to the shop. Because, we had talked about not that I'm basing everything on those numbers, but the uptime numbers from a few weeks back of like in the 80 to 90% range on the R450 machine, whereas in like the 45 to 50% range on the standard verticals. If we could be bringing the standard verticals up to like a 70 to 80% range, and there's two of them, that seems like a much higher overall yield in the shop.
Yeah.
Than getting the R450 from like 85 to 95.
Right. I think, let's see. So thinking about it, on the fly here, that makes a lot of sense to me. The reasons you got the R450 for automation, I think still exists.
They do. Yeah.
But thinking about it, yeah, I think that makes a lot of sense. The one piece I could imagine, which thinking back, because we had talked about this before you bought the machine, sort of like how ideal it would be for automation,
right,
and solve a lot of the problems we've both had with automating which basically the machines, the normal vertical machining center, with a spindle gripper, you have chip contamination on the stock. You have table space.
Mostly it was a table space constraint.
And then like getting parts out in cycle.
Yeah. Those were the main goals in my mind, was being able to get out parts in cycle. Although for us, that's maybe even less critical than it would be for someone like you.
Because they're just going to sit on a rack till they go to anodize, kind of.
Probably.
Yeah.
Yeah. Or be in a batch of 5 until they go into the tumbler. Right. But the table space thing was a big goal. Yeah. But I think I might have solved that for the other machines, potentially by lowering our walkaway, lowering our part quantity per cycle. But
yeah, I was going to say, since then, I think my focus on longer run times has actually switched, where I'm realizing that shorter run times is better during the day and longer run times is only an advantage at night. because of a few things. One is part balancing, which isn't really applicable to you because you're basically running one job, right?
Typically, which is something might be not a discussion for today.
Yeah.
I've taken it for granted that that's something I'm going to do. I kind of want to explore whether that, and it may totally still make sense, but I kind of want to explore why.
Yeah, if you can get your changeover time way down, I think it could be huge. Anyway, yeah, another time maybe. But so I would think that during the day, it's not advantageous really to go from like 20 minutes to 5 hours. It feels awesome, but it's actually really risky. Mm-hmm. Right? It's like, are they running well? Yeah. Are they loading properly in Op2? There's so many risks that actually checking in more frequently over the long term is probably more efficient. Mm-hmm. And the NRE, non-recurring engineering time of getting a reliable 3-hour run, especially as a job shop, probably is not worth it either.
Yeah.
So like frequent check-ins are good for that reason too. And it's just that having like, yeah, so I would imagine separating out running during the day and running at night would be useful and would probably point to automating the.
And as I've said, like running at night for us is really so far out in the future that it's something I want to have like on my mind, but it's not an active goal at the moment at all. Largely, I think from a scheduling standpoint, because we do run variable length jobs, they vary from day to day. There's like a high likelihood that we'll be running something that's gonna just, maybe we'll get an extra hour but there's a high likelihood, that we'll get halfway through a changeover at the end of a day and not have something fully proofed to run overnight.
Right.
It's just like we can't really, it's very hard for us to schedule predictable overnight work.
Yeah.
At least now.
That said, if someone could your pricing could look quite different to achieve an overnight run, right?
Yes.
You could basically be like, okay, I'll give you a great rate if you guarantee me X amount of work per month, and then you always run one person's stuff at night or something.
Sure. Yeah. If I'm
high volume,
I'm assuming like our work mix doesn't change.
Right.
If we were to like target that and then go for work.
Yeah. That could run.
That's a different story.
At night.
Yeah.
Yeah. So I could, I mean, I think what you're saying makes a ton of sense. Like, I think the marginal gains of going from like 80% up to 85, 90% in the R450 versus, I think you have a lot more to gain on the other machines. The other thing is like your manually loaded work is not going to go away.
Not likely.
By automating the R450.
No. And
so, in terms of like, I think that makes a lot of sense.
Yeah.
To maybe shift back to the.
It's almost the reverse. Like, focus on all manual loaded work on pallet changing machines, and everything we can automate put on the other machines, even though it seems potentially less efficient.
Yeah, I have to say, seeing you have both machines and then hearing your the numbers.
Yeah.
Those pallet changing machines make so much sense.
Yeah, thinking about the Toyota like pre-automation, automation thing, like they do a pretty amazing job of balancing kind of like cost investment for gains.
Yeah, but like the added cost of those machines is made up for in uptime gains alone.
Yeah.
And they take up the same amount of space on your floor.
More or less. Yeah.
And so rent-wise, you're just ahead.
Yeah, no, I think they're a fantastic value.
Yeah.
Yeah. It's like, there's part of me that's like, should I just sell the other machines and buy more of these? Because there's a lot.
Right.
Like, they make so much sense.
Yeah.
That's not really probably a practical
maybe,
avenue.
Although if it would prevent you from moving, like, that's money.
That's true. Yeah.
And increase your throughput by 50% almost.
Mm-hmm. It'd be interesting. Yeah.
Anyway.
Spreadsheets.
Yeah.
I think that's I have one little other thing. We had a weird shaped part that we had to laser engrave a bunch, and we're kind of like, how are we gonna do this? And I was like, 3D printer. So we just like
3D print a cradle.
Yeah, printed a cradle for it.
Awesome.
Worked great. Did it at the end of the day. Came back in the morning and it was ready to roll.
Wow. Yeah.
That's fantastic. Love it.
That's awesome.
Yeah.
I have a tiny one.
Yeah.
Sam compiled a list of tasks that can be completed in under 10 minutes that are sort of just like, like between things, or you have a weird amount of time before you have a meeting or a call, and it's like,
yep.
Yeah. So we're gonna just print it out big on the wall, and at any point, or you just need like a mental break or whatever, you can just like look up there and pick one off. So
cool. Love it. Awesome. Well,
all right.
Thank you all for listening.
Absolutely.
That wraps up our practice edition for the week.
A little rambly this week, but I think interesting.
Hopefully.
Things to explore. Yeah. Interesting to us. So.
You can find me on Instagram at lichen_MFG.
And you can find me at austere_manufacturing.
You can find the podcast at incremental CI.
Also on Instagram.
On Instagram.
And till next week.
Have a good one.